Fantastic. So look, I'm going to put an apology in right at the start. This is going to be quite rushed because I've only got half an hour and a lifetime of things to talk about. So here we go. Copper gold mineralisation in the Cloncurry District. I think it's really, really important for anybody that's working in that area to recognise the diversity within a minerals province and certainly hone in on what things are important. Right, we already have a technical hitch. So Cloncurry copper gold deposits is what I would certainly say are very much a mixed bag. When everybody talks about Cloncurry, they tend to talk about IOCG deposits, which is fair enough, but there's also lots of other styles of mineralisation across the region. Definitely a mixed bag. There's a little bit of a Queensland flavour there with the pineapple. And look, this really has some very significant implications for how we explore. I'm not really going to cover that today, but it's certainly something that's just really fundamental in how people should be exploring. Some styles of mineralisation are certainly more prized than others. I thought we'd just have a look at some general observations before we sort of drill down into the detail of what might be better. So a couple of slides here on general observations. Host rocks in terms of metamorphic grade, highly variable. So there's mineralisation in lower greenschist facies rocks right up through to granulite facies. Metamorphic grade across the region tends to increase to the south. Host rock types are highly variable. I think this is really important. There's lots of mafic intrusions in the sequence there, but that's a topic for another day. There was a major magmatic event that went for about 40 million years, which is termed the Williams-Narrow-Ku event. And I think that's fundamental to a lot of the mineralisation. Another topic for another day. Regional scale sodic, calcic and calcic iron hydrothermal alteration right throughout the whole belt makes life incredibly complex, and the age of that mineralisation is almost exactly the same age range as the Williams-Narrow-Ku Pluton event. I'm going to say typically it's not ubiquitous, but typically there's no lead and zinc in these copper gold systems, particularly the ones that have got magnetite. Magnetite is very common, but it's not ubiquitous. Pyrrhotite's common, which may occur with or without magnetite, and this isn't particularly well documented in my view. And some copper gold systems have got no magnetite or pyrrhotite. A few other further general observations. The characteristics of these deposits are really quite different. Host rocks are highly variable, as I mentioned before. It could have magnetite, it could have pyrrhotite, it can have both, it can have none. The copper to gold ratios vary substantially, and I think there's a reason for that. I'll touch on that a little bit later. Potassic alteration is really, really important, but there's skarn-like alteration out there. Silica flooding, mafic alteration. Most of the better deposits are breccia hosted, but there's shear-related ones, replacement. Mineralisation is, in my view, mostly relatively late in the deformation history of the Eastern succession. Everything's structurally controlled like it is everywhere else. But certainly there's some favourable localities at the camp scale. So there's 4 structural corridors that I've listed there. Mount Dore's got some very substantial mineral deposits associated with it. Lavuka Shear Zone, the Mount Roseby corridor. There's a wealth of copper endowment there, and the Pilgrim Fault is certainly interesting, and it's got a couple of reasonably significant deposits, and most particularly Tick Hill. But I think it's probably fair to say, other than Eloise and Jericho, there's no 2 deposits the same within the entire district. I just want to focus a little bit of time on this slide here because I think it's fundamental for Cloncurry mineral deposits. A couple of caveats: the table on the right doesn't include every single deposit that's out there, but I think it's a really good representation of what I'm trying to get across here. I put this table together late last year when I was preparing a talk for an IOCG conference in Adelaide for the South Australian people, and they asked me to talk about Cloncurry deposits and how they might fit into the South Australian scheme. And once I started to put the table together, it became really quite obvious that there was a sort of range of deposit styles. And the table is set up here such that the top of the table is the oxidised end and the bottom of the table for the most part is more reduced. And what popped out of that, I think, are three distinct groups of iron mineral associations, which are, you know, or lack of, which I think is really fundamental for how we should be exploring different styles of mineralisation in the district. On the left-hand side of the table, there's three colours there. The salmon pink ones are deposits that have been mined and no longer mining. Green are deposits that are currently in operation, and the yellow one is rocklands, and most people would be aware that got started. It's been a little messy and has now gone into liquidation. So whether that starts up again and keeps producing, I don't know. But there's not a lot of deposits active at the moment, and if you look where those green deposits sit, they're in the spectrum there between sort of pyrrhotite and magnetite dominated systems. So to group them, we've got magnetite dominated occurrences out of that table on the right. They're the mid-range copper grade deposits. They have the highest average tonnage, and they're the most deposits of magnetite related are being brought into production, and I think that's really important. The pyrrhotite systems typically have the highest copper grades and you know, commonly really substantially higher than other deposits, but they've typically got the lowest average tonnage. And the deposits that have got no magnetite or hematite and no pyrrhotite have typically got the lowest average copper and gold grades, and there's only been 2 mines developed historically of any significance, and both of those they mine the oxide material. So bearing all that in mind, I thought I would show a few examples very briefly from this table, starting from the really oxidized version and working our way down to the reduced ones, and then an example where there's no magnetite and no pyrrhotite. These slides here have got quite a bit of detail. I'm assuming the presentation will be made available to everybody, so you can go back and look at the detail. But most importantly about the Starra deposit, and a lot of this detail is also in the deposit atlas that's been put together over the last sort of 18 months. So again, that's proving to be a really useful library of information. Starra mined about 11.5 million tonnes at a couple of % copper and over 3 grams gold, and there is a much larger global resource there. But the two key takeaway points here is that, in my view, this is a genuine IOCG deposit, and we'll touch on what that's supposed to mean later. And it's got very substantial magnetite associated with it, but it's also got quite substantial hematite. Much more hematite in this system than anywhere else in the district that I'm aware of. And also significantly, in terms of copper percent to gold gram per tonne ratio, there's more gold to copper in this system, and it's the only one in the region where you could probably call this a gold copper system as opposed to a copper gold. So that being said, there's a couple of images and where it lies. Here's some rock examples, which I won't go into detail. Again, this information is in the deposit atlas. So we move on to what would obviously be in most people's mind front and centre thinking about IOCGs in Cloncurry is we've got Ernest Henry. I guess you would call it a classic IOCG deposit in the district. Dominated by magnetite in terms of iron oxides. There is a little bit of hematite. Most of it is dusting of feldspars, but there's some genuine hematite in the deposit. and the pre-mining resource was 166 million tonnes at around about 1% copper, and it's difficult to put together an actual tonnage figure for Ernest Henry, but I'm very confident it's well above 250 million tonnes and still going in terms of mining. Note the copper to gold ratio here is quite different to Starra, where this one here you've got sort of 1% copper to half a gram gold, so we've got a 2-to-1 ratio. Just another picture showing some rocks here on the left-hand side is quite a sulfide-rich example of the main ore breccia unit, and the image on the bottom is carbonate tension veins around the edges of the main breccia pipe, and on the right-hand side we've got a couple of really strongly altered intermediate volcanic rocks, and the rocks to the right of those are where they've been seriously deformed in the hanging wall shear zone and become almost mylonitic. I won't talk about the discovery history, that's all in the atlas, but certainly it's a fairly substantial magnetic anomaly. It's got an EM conductor associated with it, which is due to weathering and not the primary mineralisation. Moving on to Osborne, this is a ridiculously intense magnetic anomaly. It's 12,000 nanoteslas, mined about 27 million tonnes at 2.5% copper and a gram gold, so pretty good grade here and reasonable tonnages associated with it. The difference between the previous two deposits and this one, we're starting to get pyrrhotite in the system, so there's obviously a huge amount of magnetite to generate a magnetic anomaly of that sort of intensity, but there's pyrrhotite in this system here, particularly on the eastern side of the deposit, which has implications for how one might explore. And you'll note that the copper to gold ratio is changing, so we've got more copper to gold again. So as it's becoming more reduced, we're getting higher copper contents relative to gold. A couple of images there. Again, this is all, or most of this is in the deposit atlas. I'm not sure about this slide here. Some examples of the ore zone. The top image has got pyrrhotite and chalcopyrite with magnetite. The sample below it's a really good example of the silica flooding in there and overprinted by chalcopyrite. High-grade metamorphic rocks here. The next example is probably better described as an ISCG, and most people would be familiar with that term now, iron sulfide copper gold. But there is certainly some magnetite-related mineralisation at the southern end of Eloise. And I guess that sort of fits into some sort of transitional ISCG, IOCG, pyrrhotite-dominated system. So most of the ore is actually pyrrhotite-dominated, and there'd be parts there where there's no magnetite whatsoever. So pyrrhotite-dominated. If you look at the copper-to-gold ratio, spelling error there, it's 3.8 to 1. So it's becoming more reduced, and we're getting higher copper grades relative to gold. Here's some examples of what the mineralisation looks like. The bottom two examples are pyrrhotite rich. That's the typical high-grade ore, and this is very strongly deformed and with these dirt beaver gum textures, which essentially means that you've got ductilely deformed sulfides. So this is mineralisation that's developed in a progressively developing shear zone that's certainly active in shearing during and post sulfide deposition. The last example jumps out of the IOCG, ISCG realm in my view, and should just be called a copper gold deposit. The amount of times I've heard people mention Mount Dore in the same sentence as IOCG, it is not an IOCG. Does it matter? Probably not. But it does have serious implications if you're going to go and explore for one, because it doesn't have any magnetite in it. It doesn't have any pyrrhotite in it. And you know, those things have implications for geophysics. I mentioned before there's not much lead zinc in these copper gold systems regionally, but these ones that are typically hosted in carbonaceous siltstones and shales, and there are a couple of other examples if you go back to the table for a look, where you tend to get lead and zinc and silver associated with the copper gold, and also moly. And I guess in this example there's an extreme accumulation of molybdenum, which is called the Merlin deposit. So quite a different style of mineralisation, and you'll note that the grade is quite large tonnage but relatively low grade. Some examples of the mineralisation here, where the mineralisation is pretty strongly silicified and felspar-altered with overprinting sulfides. There's more information on those deposits in the deposit atlas, and I would encourage people who haven't looked at those to go back and have a look. But I think it's just worth investigating now what, at least my opinion, is in terms of copper gold style for the district and what moves the dial. This would definitely move the dial if they were there. Hematite dominated deposits. So South Australia, some unbelievable deposits. Obviously everyone knows about Olympic Dam. Prominent Hill is a very significant deposit of a very similar scale to Ernest Henry, and Carrapateena has not long gone into production, and you know, these are beasts and produce spectacular high grade copper concentrates if you can get the fluorine and uranium out of them. But anyway, they're magnificent deposits, but I don't think they occur in Cloncurry, and I've never ever seen a prospect that looks remotely like this. But good luck if someone finds one. Magnetite dominated, I'm going to say yes, these move the dial, and I would suggest that the current evidence says this is the style people should be focusing on if you want to go and make new discoveries. More on that in a minute. Pyrrhotite dominant, I'm going to say yes, these are quite attractive. The knowledge base for them is quite low, and from recent experience over the last couple of years, if they don't have magnetite in them, they are incredibly difficult to find undercover. But I'm very confident that there'll be some significant pyrrhotite dominated systems discovered in Cloncurry in the fullness of time. And the no magnetite, no hematite, no pyrrhotite systems, I'm going to say probably not. Now, if there's anyone watching, I'm sure that there is, that has this style of deposit, I'm not necessarily saying anything negative about those. But if you're going to go and try and find a new one, it's not my preferred style of mineralisation to be looking for, because I think the grade's just too low. So magnetite dominated ones are moving the dial for me. So if that's the case, what are the key ingredients that the good ones have? And I thought I'd just start with a sentence here that this is a ridiculously complex problem. And work needs to continue to sort this out. It's not sorted. Everybody talks about how long it's been since a significant discovery was made in Cloncurry. Well, it's been 30 years since Ernest Henry was discovered, so it's a problem, and we really need to sort it. But I think that there's still plenty of opportunities to find one. I think the compilation of the deposit atlas has been a really good start and a really key source of information for explorers. So I would encourage everybody watching to please go and delve into that data, because it is a really useful resource. Rick had sent me a question earlier today, if there's a panel discussion later, and it sort of touched on this. I guess it might be argued the only common feature to all magnetite IOCGs in Cloncurry, doesn't matter what size they are, the only thing that's common is they've got iron oxide, copper and gold, which is why they're called IOCGs. And you know, that's not particularly helpful really, because we already know that. But there is one feature that appears common in the really good IOCGs around the world, and Cloncurry's got one of them in Ernest Henry. And this potassic alteration in the form of biotite and K-feldspar, and I would argue that the K-feldspar is far more important than the biotite. You do not see it in all of the other deposits. It is so rare. There's quite a bit of biotite floating around, but K-feldspar in these systems in Cloncurry is scarcer than hen's teeth. So if you're finding K-feldspar in one of these alteration systems, you really should be having a good look at it. So there's some numbers for those deposits. Who wouldn't want to find one of those? The size and grade is phenomenal. But this is really great if you go and drill into one of these, and I think it's really important to remember too that a lot of the exploration that's likely to discover one of these really big magnetite deposits is going to be undercover. Anyone that's seen any of the presentations that Louise Corriveau from the Canadian Geological Survey has been talking about, and a lot of the work that she has been doing has identified potassic alteration has been really important, but most of the work that she does is in 100% outcropping areas. And one of the concepts she has is if you don't see potassic alteration, then move until you find some. Now that's really easy if the rocks are sticking out of the ground, but when they're covered with 200 metres of younger sediments, a near on impossible task. So if you drill into the potassic zone, undercover, testing a magnetic anomaly, happy days, because that's a really good starting point. But if you don't, you're probably going to drill a lot of magnetite, intensely altered rocks, and those altered rocks are probably going to have calcic amphibole, most likely actinolite, magnetite, epidote, albite, chlorite, synclinopyroxene. Every single one of those 4 deposits listed there have combinations or most of those minerals associated with the halos around those deposits. And so that is a real problem if that's what you drill and you're not drilling the potassic zone. Sodic calcic ion alteration, which effectively are those minerals I just mentioned previously, is very, very common in Cloncurry. Very common. And typically it's not mineralised or only very weakly. The lack of sulfide in those alteration systems, generally speaking, is quite profound. And look, there is one example in the Cloncurry region, the Swan Mount Elliot system, which would probably fit into this category here and is quite well mineralised. But otherwise, they really are pretty poorly mineralised. And there'd be a lot of people watching this presentation that have drilled a magnetic anomaly in the Cloncurry region, particularly undercover, and intersected rocks that are intensely altered with all those minerals. And you go, wow, what do I do now? And recently I've been scanning the region for opportunities and reading so many historic drill reports and companies that have drilled one hole into an enormous magnetic anomaly, got lots of magnetite, lots of alteration, exactly this mineral assemblage, and just walked away. Did that person drill down the side, stop short, drill over the top of potassic core, or did they just drill another alteration system with very little mineralisation in it? And it's a problem that's not new. Most people that are exploring there would be aware of this problem, but the issue is it still seems a long way from being resolved. Is there something we can fingerprint in the halo of the good ones that differentiates it from the other ones? Everybody has heard and had discussions around that. It's incredibly difficult to sort out. I've just listed some of the things there that have been done or looked at. I won't list them off, you can all read. Some of that has been useful, some of it hasn't. But I think the problem is a lot of it is looked at in isolation and there's no silver bullet in that list. And I really think that the answer lies in machine learning. Now, I'd be the last person, and I know Holly's probably listening, I'd be the last person necessarily to suggest we go do machine learning for general exploration in the region. But this problem is so serious and there's so many variants as to what could be the real fingerprint of the halo of these systems. But I think the only way to resolve it is to shove it in a machine and spit it out the other end and see what we come up with. And I think there's some really good evidence for this type of work from back in the early 2000s. Steve Fraser, CSIRO, was doing some work on Ernest Henry and producing these self-organised maps. Absolutely spectacular results. It was really phenomenal what types of fingerprinting you could do for the ore particularly, but also for the halo around it. It was absolutely fascinating. I've not heard anything about any of that moving forward in the last 15 years. So my last point is there an opportunity to include in the new discovery program for Northwest Queensland the chance to perhaps think about some of this machine learning and getting all of these data sets and all these problems built into a model and see what it comes up with. Thank you.